One final recording. So we're talking about deployment. There's something I didn't talk about that we need to talk about, and that is simply scalability. So in real terms, all we have on our system is a single server and a single client. I mean, that's kind of the way we've been building our application from the beginning. However, in real life, when we actually go to deploy, the goal of deployment is to start off, sure, one server, one client type thing. However, a real application would have hundreds of thousands of clients possibly. And one server cannot handle all those, not even close. So what we typically do is we scale up, and that's the notion of scalability. Well, without sessions, and this is where it gets interesting, without sessions, we just keep adding more and more servers with load balancers, and pretty quickly we can continue to scale. And you go, wait a second, that's not feasible. Yeah, it is. You can actually have a DNS request report back to any number of servers, including, 8, and then have those load balance out even further. You can have regional servers like Google, where you have DNS, local DNS servers will respond with a different set of 8 servers and so forth. And so there's no limit to that as long as you're stateless. But the caveat is we're building sessions, right? And so how do we manage that? Well, load balancers can be what we call smart. And with smart load balancers, we refer to it as sticky sessions. And what a sticky session is that when a request comes in, the load balancer sends it out to the same server. So essentially, even though there are hundreds of servers and hundreds of thousands of clients, each session is maintained by the load balancer to ensure that it goes to the same server. In other words, the server and the client are matched. This is not ideal for a number of reasons. Number one, it's very difficult to guarantee that type of connection, matchmaking. Is it possible in a small sense? Yes, absolutely. Right? This is a functional solution if it has to be that. It absolutely can work. But when we talk about the regional load balancing and so forth, that becomes impossible or next to impossible. If we have one client that remains in the same region and connects to the same load balancer, then you're great. But the second that you have the ability to connect to multiple load balancers, now we have to coordinate the load balancers, and that's when it starts to become infeasible. Now, having said that, other ways to manage it is right now we have the data in the actual server. It's running within Spring Boot's memory. What if we created another mechanism to do that? And you go, wait, what? Well, there's a variety of mechanisms. Redis is a dictionary name lookup server, and you can create one of those, and then all your servers connect to the same Redis application. And then the Redis system or a database system, a backing store, is actually managing that. Now, we're not using databases in our class, not a real database. We were using a array list. But if we were using a database, we could also store that data in the database. The databases are ideal for this, and Redis is as well, for the following reasons. Both of these servers can be managed across an organization. In other words, we can scale up a database solution as well. That's one of the things that we talk about when we look about scalability and so forth. Absolute scalability using Java JSON Web Tokens is great, but the second one of those JSON Web Tokens gets passed around in an insecure environment, it's available, right? So the data within those are very easily seen. But yes, absolute statelessness via JSON Web Tokens is great. But real sessions can absolutely be maintained in a scalable environment. Just as we were talking about the sticky sessions having a limit, essentially, the JWC and the it does carry overhead, but that overhead can be managed and can be done in a very, very, very scalable way. Okay, that is all I wanted to talk about in relation to this thing. Since we don't have a backing store, we don't have a database, we don't have Redis. and those type of things. I do not wish to bore you with the implementation of it. We're not going to actually do that in this class. However, I do want to mention that Redis, the way Spring Boot uses Redis, is it creates its own Redis server, which is not really a production thing. So if you're looking at tutorials online, be aware that that is a serious issue um, in industry. Um, there is a way to create a Redis server and replicate that Redis server separate from Spring Boot and manage it separate from Spring Boot, and that is what you should actually use. It does take a bit of configuration, so almost all these tutorials are inaccurate as it relates to that. So be aware of that. The JDBC solution works just like it's described and scales just like a typical database scaling operation, right? So it doesn't have any real effect on the scaling of a database. So the database solution is, if you see that solution online or you see that solution via tutorial, those are accurate. Those do work the way you described. Um, However, you do have to have access to a database in order to do that. All right, that ends the session part of scaling and deployment. And I just want to say that this is all theoretical for this class. We don't actually expect you to have these scalable. When we have a session state in this class, we're assuming that it's one-to-one. Because we don't have access to a database. We don't wish to have external access to a different type of server via Redis. We're just going to assume sticky sessions. Thank you. Have a great day.